All right, last one for this problem. That's A4. And it's similar to A3 in terms of the way we're going to approach it. It's just that the end result will be different. So, what did we say about piecewise functions? We always need to check the boundary point. Of course, we still need to inspect the individual functions as well. So, for example, when I take a look at that first expression, I immediately see that I have an x in the denominator, which means that I could potentially have some sort of an infinite discontinuity at x equals 0, right? But that shouldn't be a concern because in this case, I'm using this function only when x is different from 0. So there is no risk that x would be 0. It cannot be, okay? Therefore, that's fine. 2 is 2, that's easy. And I guess just the only concerning point, the only like suspicious point would be x equals 0. How did we approach it? We needed to find f of 0 exactly, like the precise value of the function, which is easy because it's just 2, right? And we also needed to find the limit around x equals 0. By the way, I actually just want to know, in this case, we're going to do that whole thing, that whole process, because this boundary value of 0 is within the interval. It is between -2 and 2. Now, if the interval was like 2, 4, then you wouldn't even care. Like, you wouldn't even check. It doesn't matter. But in this case, it is within the interval, so we need to check what happens. So how do we calculate the limit as x approaches 0 of f of x? Now, again, as x approaches 0, we're definitely not going to be here. That's for exactly x equals 0. When x is different from 0, even if it's very close, we're working with this expression here. So I'm going to have limit as x approaches 0 of x squared plus 5x over x. Now, if I directly plug in 0 for x, I'm going to get 0 over 0, right? You can probably see it. So I'll need to somehow modify the expression. That was actually very easy. We don't have any quadratics or formulas. I can just factor out one x in front in the numerator. So that's going to be x times x plus 5. And then in the denominator, I'll just have x. So I cancel things out. And then I just plug in x equals 0. So that's going to be 0 plus 5, which is 5. However, that 5 that I just got for the limit is different from the value at 0. So whenever you have the two-sided limit, because sometimes you might not even have the two-sided limit. Sometimes you might have different limits on the different sides. So this will be D and E. But in this case, not just in this case, whenever you have the two-sided limit, but it's different from the value at the given point, you have a removable discontinuity. Okay, so how do you write this down? You write in the following way: f of 0 equals 2, which is different from the limit as x approaches 0 of f of x, which equals 5. Therefore, we have removable discontinuity at x equals 0, okay? And then the third possible case that we didn't see in these problems, but it is possible, is that even the two-sided limit doesn't exist. So if you have, so what we currently have, okay, let me just quickly graph it, I guess. So at x equals 0, the value of the function is 2, okay? However, the limit, so as x approaches 0, the limit goes to 5. Where is 5? 5 is here. Okay, so the function, I don't really know how the function behaves. So the shape that I'm gonna draw now is most likely incorrect. It could be anything, but the trick is from both sides, it approaches 5 as it gets closer and closer to x equals 0. But precisely at x equals 0, it's actually not 5. Oops, oh my god, wait, I didn't want to remove all this. It's actually not 5, but it's 2. So why do we call it a removable discontinuity? Because if we were to ignore that point, then everything else is just like smooth, right? It's a removable, like one point that's off. For the jump discontinuity is quite different. So how would the jump discontinuity look? For a jump, even like the two sides wouldn't be approaching the same value. In this case, both sides are approaching 5. But for jump discontinuity, the other function might be approaching a totally, not the other function, but like the other piece of the function could be approaching a totally different value, not even that thing, okay? So that's the difference between the two.